Okay, today we're going to have a look at our new topic of binomial distributions. So a binomial distribution describes events that have a success or a failure. In other words, the only two options are it occurring or it not occurring, like getting a heads when tossing a coin. Now, other fields of probability do exist to investigate more variables, such as chi-squared or t-distribution, which can change the number of variables dependent on something known as degrees of freedom. Now, degrees of freedom is a very, very easy yet glossed over concept in this course, and I'm pretty sure it's something that's covered in extension science in that syllabus there. So, the first thing we're going to look at is the idea of a Bernoulli distribution. So a Bernoulli distribution is a discrete distribution for a random experiment that has exactly two outcomes, 0 or 1, a success or a failure, where a success is denoted as P and a failure is often denoted as Q, which is going to be 1 minus P because probabilities add to be 1. So officially, a Bernoulli distribution is defined as the piecewise function p of x equals x, where we've got the probability of p, we've got 1, and then 1 minus p, x is 0. So we're going to identify that these are whether they're Bernoulli or not. So you pass or fail an examination. So you either pass or you fail. Yes, it's Bernoulli. Part B, a die is rolled, and a die is rolled and a 6 is the result or not a result. So you've either got result or not a result. So a 6 or not a 6. So yes, it's Bernoulli. A die is rolled and a number is recorded. Well, we could say X is the set 1, 2, 3, 4, 5, and 6, as opposed to the set up here being 0 or 1, you pass or you fail. Same idea, X is the set 0 or 1, you pass or you fail. So no, this is not Bernoulli's because there's not only two options. Asking a person, did you spot a whale? Well, the two options are yes or no. Or you could say 1 is yes and 0 is no, it doesn't really matter. But did you spot a whale, yes or no? So yes, it is Bernoulli. Hitting a bullseye when throwing a dart. Well, if you hit a bullseye, you either hit it or you didn't hit it. So yes, it's Bernoulli. There's only two options. Asking a student whether they walk, ride a bike, or catch a bus to school. Well, this is going to be the set of three options. So where 0 is walk, ride a bike is 1, and 2, not 3, is catch a bus. And part G is drawing two cards and obtaining exactly 2 hearts from the pack of cards. It's unclear in this experiment whether you are obtaining with replacement or without replacement. If it was without replacement, then the probability, then it would be Bernoulli because you're taking it out and then you're not putting it back in. So you can either get 2 hearts or not get 2 hearts. But if it's with replacement, you're putting it back in, well, that's changing the probability. So we would say that it's not Bernoulli. Okay. Example number 2, write a Bernoulli probability distribution for each situation. Passing a test where we've got the probability of passing is 50%. So we're going to say the probability of x equaling x is equal to the piecewise function. 56% is equal to a pass, that's for x is equal to 1. And it's going to be 44% for failing. That's when x is equal to 0. And we're going to say to the side where 1 is equal to a pass and 0 is equal to a fail. Flipping a head on a coin. So the probability of x being equal to x is going to be 0.5, 0.5 for x is 1 and x is 0. And we're going to say 1 equals heads or tails, doesn't matter, and 0 is tails. Generally though, since we're after heads, we're going to set 1 to be heads and 0, which is fail, to be tails. Part C, we've got selecting a ball at random containing 7 red and 8 white balls. So the probability of x being equal to x is equal to, well, the probability of getting a red ball is going to be 7 on 15, because there's 15 balls, and that's for x is 1. And we might say let red equal 1. And the probability of getting a white is going to be 8 on 15 for x is 0 if we say white is equal to 0. Okay. The mean and variance of a Bernoulli distribution. So we would have seen in our study in advanced, and you've seen it in year 10 maths and maths previous before that the mean of a distribution is the average and the variance is the square of the standard deviation. And remember, standard deviation is how far apart my results are. One standard deviation would mean that you're one standard deviation above the mean. So standard deviations often are used to determine how far up and how far away from the average you are. So we know that the expected value, which is another name for mean, well, it's equal to the sum of x times by p of x if the distribution was called p of x. And the sum of x p of x is going to equal, well, if we have a look at our distribution, the x's are all going to be 0. So 0 times 1 minus p, 0 times 1 minus p, plus 1 times p. So the the expected value of the mean, the average, is p. Now the variance formula, if I just move this over to here, the variance of r of x, the formula is the sum of x minus e to the x squared times p of x. So that's our formula for variance you would have seen in advanced. So 0 minus p squared times 1 minus p. So we've gone x is 0. Where are we? X is 0 and we're minusing p times by 1 minus p. And then we're adding 1 minus p squared times p. And if you simplify that, you get p 1 minus p if you expanded all of that. So therefore, that is the variance of a Bernoulli distribution. And that's our symbol for variance, standard deviation squared. So this next example, we're going to calculate the mean and variance of each of these Bernoulli distributions. So we can tell that these are both Bernoulli distributions because I've got 2 outcomes, pass or fail, 0 or 1. So the mean, which is the expected value of x, now the expected value of x is the expected value when this instance is true. So the expected value is a success. That's the expected value. So 0.6. So if this was rolling a dice and we wanted to get a 6, I know this is not the same probabilities, but if we wanted to get a 6 and we're going, okay, the probability of 6 might be 0.6. So that's the probability of 6. So that's the expected value, what we're expecting from a success. And because it's equal to p, therefore the mean is equal to 0.6 because the expected value is equal to the mean. In other words, you're saying that the expected value is equal to p, and p is the probability of success. Okay, now we want the variance. So the variance is just equal to the formula. We're just looking at 0.6 times by 1 minus 0.6, which is 0.24. Okay. Again, the mean, the expected value of a Bernoulli distribution, is equal to the probability of success. So the mean is that when p of x is equal to 1, which is 3 on 5, so 3 on 5, and so therefore the mean is 3 on 5. And the variance, the standard deviation squared, the formula is p1 minus p, so it's going to be 3 on 5, 1 minus 3 on 5, which is 6 on 25. So that's our variance. Okay. And that's the idea of Bernoulli distribution. Thank you.